everyone. I'm Shotade Olusegun. This afternoon, I want us to look at the validity and authenticity of formula of everything. Well, in today's video, we're going to look at what the past scientists have been trying to do to achieve a relativistic wave pattern that can actually work very well with Schrodinger equation. So now in 1927 there is a survey conference. So in that conference, the title of the conference is Electron and Photon. Well, prior to that time, Einstein has developed special relativity in 1905, and so he gave us this equation where we have energy, then we have square root mc squared plus pc squared. So the p stands for momentum, then c is the speed of light. So this formula, what this formula does is that it time relativized space, and there is where the first problem is. So in special relativity, Einstein made time to relativize space. So we're going to look at why it is not supposed to be so later. You understand? And in 1928, Schrodinger developed another quantum wave. So we call this Schrodinger equation. So it actually starts with Hamiltonian, which is dealing with the kinetic momentum of the classical formation and potential energy. So now the sum of kinetic energy and potential energy will give you Hamiltonian. So the Schrodinger equation starts with this, and what Schrodinger did was he tried to to model the dynamics of energy and momentum by using differential calculus. And when he did that, he was able to actually come up with the wave equation. But there is something he did in the equation. He made the derivative of the time to be first order, while the derivative of the space is second order. Now, what Schrodinger modeled in his wave equation, that is the ideal nature of Einstein modeling of space-time, because Einstein modeled space, the whole 3D space. He modeled it as a x-axis, just as what we have here. So when the 3D space is being compacted, and then we have it on x-axis, and then the vertical line, which is y-axis, now represents time, the fourth dimension, which is for time. Now this kind of coordinate is not ideal to illustrate the expansion of space, especially cosmological space. It's not ideal to explain it, and there is where the first problem is. Now let's look at this chart. Now you see that when time increases, when you make time wide by scaling, then the scaling of time relative to time, the scaling of space relative to time has to be narrow. So when you extend time by scaling it wide, then the space we have to scale narrow towards the central 0 point. Now same thing, if you widen the space, then relative to time we have to scale narrow. It will have to scale narrow towards the central 0 point. Now, what is this telling us? What is the implication of this? The implication of this is that when you are trying to model the expansion of space, as you have time being relative to space here, it will mean that when the time is scaled wide, then the space as well we have to uh, scale wide relative to time. So if that's what we have, then it's going to follow this pattern. That is, when time scales wide, then uh, space too must scale wide. But the challenge with this is that um, if we have it like this, then it is not relativistic with time anymore. Because when you have space being relativistic to time, then when time is scaled wide, the space will have to scale narrow. And you can see that discrete nature of space to time in that kind of relativity. So it doesn't illustrate the continuous nature of space expansion. And so this cannot be used as the fabric of the universe. And that is why in my own model, I have to say time relativize, or I have to use time and energy in relativity. So time can only relativize energy. And so when you have the expansion, you will see the evolutionary expansion of space itself. So this time energy wave model actually illustrates and it better explains the expansion of the cosmos than what Einstein developed. So that is where the first problem is. Now, in Schrodinger wave equation, Schrodinger actually modeled the space the way it ought to be. And don't forget that this Schrodinger wave equation is not relativistic. It's not relativistic because it is not modeling the relativistic nature of particle. You understand, in space-time as we have for Einstein space-time. So now, then in 1928, Dirac now had to develop another relativistic wave equation. So before Dirac, before the invention of this relativistic wave equation of Dirac, there is another relativistic wave that came on board. I think it was in 1926 by Klein. By Oskar Klein. Now, what Oskar did in his own relativistic wave equation is that it takes square of, you will have to get rid of this square root. Probably you will extend this by Taylor series or any other series. So now, instead of taking the square root, he take the square of both sides of the equation, and then in his own differential calculus, then he had a second derivative for time, and he had second derivative for time, and then second, probably if we also have second derivative for space. Now, what that is telling us is that when you have second derivative for time and space, you are actually modeling this portion, the gravity phase of this time energy wave model. That's what he had in his own equation. Now, when you have, in the case of Schrodinger, where he had a derivative of first order for time, it was like trying to model this portion of time energy wave model, and then all of a sudden get disconnected, and then modeling this part for space. That is the implication. So in that case, we have the illustration of discrete nature of a quantum wave. You understand? Related to the Einstein's space-time formation. So now in Dirac's relativistic wave equation, there is something so spectacular, something so unique and so powerful in its equation. And that is why Dirac was a little bit closer to discovering the reality of the universe as we now have in this formula of everything and time energy wave model. Because in Dirac's equation, he was able to get which the suspension which is the same thing as what we have in this time energy wave model, where we have the mass formation being suspended, and then the quantum mass what being suspended as well. It was able to discover that, and that was 0.5 mega electron volt. And then it was even able to discover the negative state, which is the state outside this time energy wave model. And by applying formula of everything, I said that before we can actually get the real mass worth of electron, then the trajectory we have to travel beyond this time energy wave constraint. And as a result of that, we already have the formula that has exceeded the speed of light. And so when you now travel down into that negative state where you will be able to get the actual uh, electron mass, then that mass will also be taken back into this time energy wave model, and it will be compressed in that small space, and that will increase the intensity of the acceleration along the gravity phase. So I will explain more on that. But now, what is the implication of having negative state like this? By having that negative state, just as Dirac discovered it, Dirac realized that by having that, it's actually saying that the relativistic particle cannot actually go through the singularity to other side. You understand? Because you have a negative state relative to this positive state. And based on the Pauli exclusion principle that states that particle or electron cannot occupy the same state in atomic state, energy state. And based on that, then it will be forbidden for the particle at this realm to travel to that negative state realm. It will be forbidden because the electron that you have in that physical particle realm will also be occupied in that unseen negative realm. So they can't just occupy that same. So no particle can actually travel from here to that unseen realm. Now what Dirac now did to solve that was, but before I explain what he did to solve that, there is something when Dirac was like trying to have his own relativistic wave equation. Instead of taking square to get rid of this square root, he decided to take the square root. And to do that, it is so difficult because by the time you extend, and by the time you extend this in a Taylor series or any other series for that matter, you will discover that you will need alpha coefficient, and that alpha coefficient, if it has real number, then it will commute. You understand? For that reason, there is a challenge in taking the square root. And then what Dirac now did was he realized that Pauli used matrices. So there is something called Pauli matrices. He realized that by using matrices to solve this, then it doesn't necessarily it doesn't necessarily mean that the something should commute. I mean, so the effect of commute has no more effect. With that, you can actually take the square root. So now, by the time this is being extended, don't forget that in the Einstein's relativistic equation, I mean, in Einstein this relativistic equation, there is power of 4 to we have power of 4 in the equation, and for that reason, when it is extended, then there must be uh, Pauli matrices for the 4 sections of the extension. You understand? But the issue now is Pauli matrices has 3 matrices that can actually explain why the uh, sigma there is sigma 0, why the sigma 0 part of the extension has no matrix uh, to prove it. You understand? So what Dirac did was he developed 4 by 4 matrices, and he was able to solve that, and he now took the square root, and he was he then was able to get the first derivative for time, and as well get first derivative for space. Now what Dirac was doing in his relativistic equation, we can liken that to the expansion phase that we have in this time energy wave model. You understand? But it can, it has first derivative for space and also for time. So what is actually saying in that context is that when time is scaled wide, then space too should scale wide. So it was like trying to model the expansion of space the way it ought to be, and that is why his own formula is more powerful than other formulas. You understand? So now that we have that, so he was able to develop his formula, and so we had the relativistic wave equation, and that wave equation discovered negative energy state. Then that wave I mean, that relativistic wave equation discovered suspension. Those are the powerful things that the wave equation discovered. Then another thing you need to know about Dirac is that Dirac had what is it called? Large number hypothesis. And if you look at the constant of formula of everything, you can see that the constant is very large as well, where you have 2.5 times 10 raised power 39. That is the constant interval. So it is more wider than what Dirac discovered in his own large number hypothesis. But Dirac did not get the formula in such a way that the formula could actually travel back and travel through the singularity to go into that negative state, to go into the negative state. You understand? So now Dirac had to develop another vacuum, another state for vacuum. No, when you're trying to develop vacuum, you are trying to have a state where there are no resistance. Where there are no resistances, you want to have a state that is void of any resistance. But what Dirac was saying in his own new developed vacuum is that there is no way you try to get rid of resistance, you try to get rid of electron, you will still, that you want to have the zero ground resistance, you will still have a negative state. So in that, he now modeled the negative state as a state that is being occupied by electron. You understand? So now your physical state that is occupied by electron will be inversely related to that negative state. That is what he developed to solve the problem. And so when you have a negative state that is being occupied with electron relative to physical state that is also being occupied with electron, then based on the Pauli exclusive principle or Pauli exclusion principle, then the no particle of electron can travel from the physical realm to that unseen realm, to that negative state realm, because they have equal, the electrons have occupied the same state in the two realms. So that is why there is issue. And if we have that kind of situation, it simply means that there is no possibility for relativistic particle to travel beyond the 0 point, the singularity point, into that negative state realm. You understand? So the way Dirac was able to solve that, he said that when there is a huge decaying mechanism or radiation, then there could be a possibility for development of holes inside the negative state, uh, uh, inside the negative state of electron. You understand? So when we have hole inside the negative state of electron, then the hole will serve we serve as positive charge, and it will serve as positive energy. In that case, then particle can travel from the physical realm into that unseen and negative realm. So that has been solved, and it is for that reason that we do not have problem with this formula of everything and time energy wave model as to how particle can travel from this physical time energy wave into the unseen realm, where we have streams of what I tag efficiency energy. Now here I tag this efficiency energy because by the time the trajectory travels beyond this limit, then it will go and then get the actual value of electron. That actual value of electron, we because before this can be gotten, then we have to have extended energy beyond its limit threshold. And when you extend energy beyond its limit threshold, then you take it to superconductivity level. At superconductivity level, then we have, there is where you can get full efficiency energy. And so that is why I tag this outside region as efficiency energy. And so once it gets there, it will get the actual value of electron and gets back into that small space. And then the field of that additional or excess value or excess mass worth will cause acceleration. And because of that speed difference, that is why we have in this gravity phase what is known as entropy. And apart from having entropy, we see that I had explained in my in one of my previous videos that the speed difference is what compensates for mass worth balance in classical or at classical level. You know that when gravity acts on object at classical level, it will act equally on those objects irrespective of their mass or size. So that balanced effect of gravity is compensated for by the speed difference factor at quantum level, and that explains what gravity stands for. So good. So now we particle can then travel from this physical realm into the unseen realm to get the actual value of electron mass and then put it inside a small space to actualize that speed difference factor. Then another thing that we need to know is that same thing here we have at this phase. This is a momentum phase, this is position phase. Under this we have potential energy, because same thing will happen here too. the trajectory must travel beyond to get into potential energy and then convert it to energy density. In momentum phase, we have convergence of energy density, but in position phase, we have convergence of mass worth, and we can just name that mass. Then another thing you need to know, because I will have to relate this to nuclear fusion, then nuclear fission. Now, this phase can be likened to nuclear fusion. Why this phase can be likened to nuclear fission? Nuclear fusion is the merging of, for example, deuterium and tritium to form bigger mass. Why the nuclear fission is the decaying of mass into singularity. So now, what I want you to know is that don't forget that this time energy wave model and the formula of everything is being modeled as chains of inverted versions or dimension. So the universe as we have it is interwoven. So we have time energy tapestry in the universe, and that is the actual fabric of the universe. So in my other videos, you'll be able to see how I said that time energy wave model is the actual, like time energy tapestry is the actual fabric of the universe, because it illustrates the expansion of space better than the Einstein space-time formation. So since it's chain of inverted versions and dimensions, so what this is telling us is that the full realization of an entity or of a particle, for instance electron, is not within the physical realm. It is actually beyond. And so at the birth of new element, then the full realization of electron will be obtained. What do I mean by that? Now let's look at the nuclear fusion. Nuclear fusion, deuterium, they are the deuterium and tritium, they are isotopes of hydrogen. Now, when they are at the point of merging, the repulsive energy now becomes intense, and so they will need additional energy, additional force to actually override that repulsive force. And once they are able to do that, they will merge and form bigger mass, which is helium. Now the helium is now bigger in mass, and as that is bigger in mass, it means that at the birth of helium, which is new element, then the full potential of hydrogen will be obtained, and then it will go back into its physical domain to effect the speed difference factor in its domain. So you can see the effect of chain in what I just explained now, and that is why the universe is more or less like chain, just as what we have here. You see time, and every side is invertedly related to one another or to each other. The up region to quantum region is inversely related. The past and the future is inversely related, because you can see that here we have expansion, here we have contraction. Here, up here we have expansion, and down here we have contraction. So when you watch my other videos, you'll be able to see that the interaction of time energy at quantum level is being contracted to have that speed difference factor, while the expansion at the classical level is not being contracted, and that's why we could have a free fall gravity effect. So good. Now the essence of momentum is to toggle between mass density and energy density, and then we can see that they are interwoven more or less like the interconnectivity of chains, and that is why it is ideal for you to get the full potential of the parial element at the birth of the new element. So that is that. With this, you can see the validity and the authenticity of formula of everything in what I just explained. And that is what the likes of Dirac, Oskar Klein, and some other scientists of the past have been trying to achieve. But the problem is that their whole relativistic equation is being limited at quantum level. They do not see beyond to see that relativistic effect can actually unite quantum mechanics to classical mechanics. That is number one challenge they have. Then the number two challenge they have is that this time space is not the ideal structure of the universe, because it doesn't model the expansion of the cosmos the way it ought to be. That's another challenge they have in their own equation. And thank God, by God's grace, I could figure out that those challenges, those problems in my own formula of everything and the time energy wave model. Then another thing I want you to pay more attention to is that this is a novel discovery, and as you can see all that I've been explaining since are beyond human comprehension. So I'm just a mere vessel that God used. I'm a mere vessel that God is using to pass this information across. And then this novel discovery will advance science more than we can imagine. And now we have an end to that stagnation that we have in science advancement all this while. So I believe this video is quite insightful and informative. Please make sure you like this video and make sure you share the video with your friends. Most importantly, make sure you subscribe to this channel so as to be notified for the subsequent videos as I upload them. Thank you very much. God bless you.